I touched a little bit with some graphs as how to look at domain and range, and I'm sure you may remember it from algebra, where domain just tells us the series of x values that are allowed. But we haven't applied it to a formula, so I pulled a couple of these from the example book, and I want to share it with you. And here's the gist of it. When you have a domain, two things are not allowed, and I'm going to show them to you here. Something divided by 0, that's a no-no. And the square root of a negative number, that's a no-no. So I want you to keep these in mind. Those are the two rules for domain that are not allowed. Divide by zeros and square roots of negative numbers. That produces non-real answers. So for us, when we look at the first one, we see x plus 4 divided by x squared minus 9. And they say, find the domain. Well, what they're saying is there a divide by 0? Let's find out. Can I make this equal to 0? Let's just ignore the numerator. I would add 9, and you get x squared equals 9. And when you take the square root, you're going to get x is equal to 3 or negative 3. So we've actually found two places where the domain would not be allowed, as there is a divide by 0. But everything else is allowed. So we would write something like this. For x, x... all real numbers, you can write this a million ways, but you have to say x does not equal 3 and x does not equal, let's do it this, for all x. So you say it's not equal negative 3. Your teacher is going to show you the way they want you to write it. And this just means all real numbers. It's just a special looking R because it makes math look harder, and we like to do that. This is all it takes, is you found there's no square roots in this. Right? There are square roots of negative numbers. There's just a divide by 0. So you find wherever it divides by 0 by solving the numerator or the denominator for 0, and then you say this is where it can't do that. So in this case, all real numbers are allowed. 7.216 is allowed. You just can't use 3 or negative 3. Let's look at the second one here, if I can hammer this home a little bit. It's simpler than you're probably making it. I find that I and most of my students get lost pretty quick trying to understand domain. Let's look at the next one though. Okay, we have a 2t minus 1 under a cubed root. What's a cubed root mean? Well, let's think of the opposite. Like let's take negative 3 times negative 3 times negative 3. You would get negative 27. I hope you know that if you're walking into calculus. So that means the cubed root of negative 27 is negative 3. And what that also means is that negative numbers are allowed. This isn't a square root, because a square root, if I do negative 2 times negative 2, you get positive 4. So if I gave you negative 4 inside a square root, that would be impossible, because nothing creates a negative number when you multiply it by itself. Negative numbers that multiply create a positive number. So that's why you can't have a negative square root, but you can definitely have a negative cube root. And in fact, you could even solve this if you wanted to. You could say like, let's say this equals x. And we want to make it into something that we can't allow. Like we can manipulate this around a little bit just to convince ourselves. My computer's being slow. So we cube each side to get rid of the cube root. We'll make it x cubed. And we'll add 1 over. So we're going to get t is equal to x cubed plus 1 over 2. I can't think of a scenario where t would create some problem. Any number can be cubed, so this domain is actually going to be all real numbers. There's nothing wrong with this function at all. Isn't that interesting? So be careful when you're looking at domain and you just say, am I able to divide by 0? Am I able to create a square root of a negative number? And if so, bam, you found the discontinuity in the function.